Welcome to our AP Pre-Calculus video. This is Coach Meinbauer. We're going to cover section 2.10, which is inverses of exponential functions. So we're just focusing on inverses and see what they produce. From Algebra 2, we should know what these do to produce, and they do produce a log. So we're starting to talk about log just a little bit here. So there is a definition of log functions right up there, what they look like. It's a times log base b, which is a subscript of x, where b has to be positive and not 1. And a cannot be 0, otherwise it just becomes a 0 function. So some facts about log functions, we'll kind of go over this as we start graphing this anyway. But what's good to know here is that log base b of x and b to the x are inverse functions of each other. So please take note that those are inverse functions of each other. Okay, and then the other thing here for inverse functions is that they're always reflected over the line y equals x. Okay, so we have a 2 to the x, which is shown right here. And by the way that I graph 2 to the x, and I showed this in a previous video, is always just use -1, 0, and 1 as my x values, and I plug them in to get 1/2, 1, and 2. So you can see right here, those values are holding true there. So now let's go ahead and do the inverse of that. So inverses are when you switch the x and the y. Okay, so inverses are when we switch the x and y. Okay, so the way that I'd graph the log, I'm actually not going to even use this table to graph the log. I'm going to kind of ignore it. Is when I make my x and my y chart, instead of my x's being -1, 0, and 1, I'm going to go at my y side. Okay, and then so this is going to produce a 1/2 here, a 1 here, and a 2 here. So there's just inverses of each other. So if I'm graphing this at 1/2, I go down 1, go over 1, I'm up 0, and go over 2, up 1. The graph looks like this. Okay. One little tidbit that I'm missing here is logs are going to have asymptotes. So vertical asymptote for logs, and then horizontal asymptotes for exponentials. And if you look right here, we should have a mirror image. This is the line y equals x right here. You notice that we are mirror images. They can fold over from one onto the other. So let's get into some problems about this. So we're starting to relate inverse functions, relate log functions with exponential functions. And then so determine if the function is logarithmic, exponential, or neither. So what we're looking is the output proportional over equal lengths, or is the input proportional over equal lengths? So we'll talk about both of those ideas here. So for this first table right here, as you can see, the only thing that's happening is we're multiplying the outputs by 1/2. Since the outputs are changing, this is going to give me exponential. Okay. Over here for B, the only ones that are proportional here is going to be the inputs. You can see that we're multiplying by 3 every time. So since it's just the inputs that are proportional, this is going to be a logarithmic. Here, a little tricky. Looks like we're multiplying by 10 every time here on the inputs. But we're doing the same thing on the outputs. And as I mentioned before, they have to be proportional only over equal lengths from the opposite. What I mean by that is if inputs are proportional over output being equal lengths or vice versa, then it's going to be log or exponential. But since these are not over equal lengths here, the outputs are proportional, but the inputs are not equal length. Inputs are also proportional. So this is going to be neither. Okay. You can try D on your own and hit pause and see what you got. And we're back here. So we're going to get this to be times 2. So since the inputs are times 2, that's going to give me logarithmic. Okay. If you notice that my outputs, they are changing by -3 every time. That's over an equal length. All right. Just some properties here as inverses. If we take a composition function here, which just means that we're plugging in the log into the exponential or the exponential to the log, it will produce just an x. Okay, so this is important to know for inverses. This is an inverse property that you do need to be aware of. Okay. So we talked about this already. Graphs of inverse functions are a reflection of each other with the line y equals x. And then I talked about this in the previous page right here. This is just when we switch our x and our y's here. If you notice, my x's and my y's just flipped over. If you have an x1, y1 turns into y1, x1. Okay. So here's our example. We're going to have f of x is 3 to the x. G to the x is log base 3. Show that f and g are inverses of each other by showing the following. So we're going to go ahead and do that. So we're going to start with f. And then so f of g of x, which is log base 3 of x, means that I'm going to take the x value for f and rewrite it as a log. And the log and the exponential are going to cancel out from each other. Okay? So they're going to cancel out and they're going to equal x. Okay? And then we're going to do the same thing here for g. So we're going to do g of 3 to the x equals log base 3 of 3 to the x. And this is actually a log property where those are going to cancel out and we just equal x. So it's all we're doing right there is just showing that they are inverses of each other. And that's going to wrap up our video here for 2.10. Do not forget to like and subscribe.